Hello again. We got cut off on the previous part for part 1. So let's start where we left off at. We're still dealing with graphing inequalities. So for this particular one, hopefully you can see the inequality. So let me zoom in just a little bit. We have x plus 8y is less than 8. So let me switch it out just a moment and then zoom out for you. Alright, hopefully you can see this. So I know it's a less than, so I know that's going to give me a dashed line I'm going to shade under. You want to make it a little bit easier to graph in regards to point slope form. So I subtracted x from both sides, bring down my 8y. Then I have less than negative 8, negative x plus 8. Divide everything by 8, so my simplified version is y is less than negative 1, 8 plus 1. So we're going to graph it real quick. So we got a positive 1 on the y-axis. I know it's the y-axis because it says y. So there goes positive 1. Now look at our slope. From that positive 1, I'm going to go down one time because it's a negative 1. And always go right. So here I'm going to go right 8 times. It's going to be a dashed line because it's a less than, as indicated right here. And then we're going to shade under. So I'm going to inch this up just a little bit and zoom out so you can actually see the steps that were written out. So when it's your turn to actually try to do this, you already have the steps. In just a moment, I'm going to show you what the graph actually should look like because this is definitely a rough sketch. So here we go. That's what our graph should look like. We have yet another inequality. This time around is a greater than or equal to. So let me zoom in. Now because it's a greater than or equal to, we're going to assume that we're going to shade up. And it's going to be a solid line because it has half of that equal sign. So let me show you. I'm going to go back to this graph in just a moment. So here we go. As previously stated, it's a greater than or equal to, so I'm going to connect my dots with a solid line and shade over. We want to put this in slope-intercept form, so when I put it in slope-intercept form, I'm going to subtract x from both sides, bring down my 6y greater than or equal to, then I have negative x plus 0, divide everything by 6, so the y by itself, bring down your greater than or equal to sign. Notice how you see a negative x, use just one x, so bring down the negative 1, is over 6. Then you can't divide 0 by 6, hence you just have the negative 1 6. So when we do our rough sketch, we're going to start at 0 because there's nothing here. From that 0, I'm going to go down 1, and I'm going down because it's a negative 1. And always go right 6 units. Now again, this is a rough sketch. I'm going to connect my dots with a solid line. And because it's greater than, I'm going to shade over. So let me pause for a moment so you can jot those steps down. Now remember, feel free to go back and rewind to look at what the inequalities mean. When it's going to be a dashed line, when it's going to be a solid line, and when it's going to be shading over and shading under. So here's what the graph looks like. Just like mine, except the shading is a little bit better. We have yet another one. So those are your inequalities yet again. Now from looking at the inequality itself, I know that I'm going to have a dashed line and then I'm going to shade over. Well, let's see why we did that. Your y-intercept is negative 1, so here's where, negative 3. So that's where we're getting the negative 3 from. From that 3, go down 3 because that's a negative 3 right here. So go down 1, 2, 3. And then always go over right. So this time you're going to go right 2 times. Connect your dots with a dashed line and shade over because it was greater than. We got a lot of inequalities, y'all. We have our last, well, not quite our last. Here goes another inequality. Take a moment to actually look at it and see if you can determine why is it a horizontal line. Now you may remember earlier when we were doing the equations, we had to draw a horizontal line when it was pertaining to the y-axis and we drew a vertical line when it was pertaining to the x-axis. Well, here we go with a y. So I'm going to plot a dot at -7 right here. And then I'm going to draw a horizontal line going through the -7. Once you draw that horizontal line, shade over, hence the green, hopefully you guys can see it, because it says it's greater than. So in summary, in regards to the inequalities, make sure, again, you wrote this down somewhere. Feel free to pause the video and rewind. Now we're going to get a little bit into more details in regarding linear equations in their line themselves. So let's look at this one. You see the graph and you see a diagonal line. Hopefully you also see the points where you have 1 and 2 and 3 and 5. So it's asking you to find the slope and then graph it. Well, let me show you how to do that. One of the ways that you actually can find the slope is using the slope formula. The slope formula itself is y2 minus y1 divided by x2 minus x1. So given to you were your 2 points. Notice how I labeled them so I knew exactly what to substitute. So I have 5 minus 2 gives me 3, 3 minus 1 gives you 2. So boom, bam, pow, I got my slope. Let me show you how to actually graph it now. So notice how you have graphed your points. So your first point is 1 and 2. So here goes my 1, go up 2, plot your point. Your next point is 3 and 5. So go to 3 on your x-axis and go up 5 points. Plot your point, connect your dots. So remember that your x come first and then your y's when you're looking for your x and y coordinates. In regards to coordinates, here goes a problem that's asking you to find the slope. I have to read it to figure it out. So here we go right here. So now that I have that, let me show you what you want to do. You can either convert it to slope-intercept form, or we can keep it in standard form. So let me finish this one out first. So that's going to be 2x plus 5y equals -10. So to make it easier, I'm going to say keep it in standard form. Because if I continue on with the other ones, it's going to be a little bit confusing. Now remember, standard form is ax plus by equals c, where your slope is negative a over b. So a was 2, make it negative b was 5. So wow, made that a whole lot more simple. Your slope is negative 2/5. So my apologies for trying to start that off and then did not finish it. However, feel free to use Mathway as another resource to help you guys out. Here goes our next example. Once again, it's pertaining to graphing. And I did not realize I had zoomed out that much, so my apologies, y'all. Okay, so let me zoom in. It wants you to graph the line that passes through the given point and has the given slope. Alright, cool. Now what we're trying to figure out is what is what. So let me give you a moment, or give myself a moment to actually do it the long way, and then I'm going to show you how to do it the easier way. Okay, so when we're graphing it, we have a point at 6 and 2. So here goes my x-axis at 6, go up twice, here goes my first point. From that point, I'm going to go up 2 times. So let me zoom in so y'all can see what I'm talking about. Here we go. So from this point, go up 2 times, 1, 2, and go to the right 3. 1, 2, 3. Connect my dots. So that's one way of doing it. The other way doing it manually is this way. So we had a given point of 6 and 2, and then we had a slope of 2 and 3. So I've already showed you how to do the graph. When I say go to the graph, we've already done that. So I'm going to use the point slope formula, which is y minus y1 equals n times x minus 1. So my points, so for clarity purposes, let me label them. So that's x1 and y1. Substitute your values in for x1 and y1. Once you substitute them in, use the distributive property. So now we have 2x minus, well, 6 divided by 3. I'm sorry. 2 times 6 is 12, and 12 divided by 3 gave us this 4 right here. That's where the 4 came from. So again, 2 times 6 is 12. 12 divided by 3 is 4. To put it in slope-intercept form, add 2 to both sides. So now we have our line as 2x minus 2. So yay! That was quite a bit in one time. The next one, let me zoom in, is like this. You have a slope of 3.7 and then a slope of 4.9. It wants to know which one is steeper. So before we go into that, let's understand what steep means. It's just like how steep stairs or mountains are. So it'll be more of a vertical line, the steeper it is. And it'll be more of a horizontal line, the flatter it is. So I worked it out on a separate sheet of paper. Let me zoom out so you can see it. So in regards to your slope, you have 2 different equations. And those are, I'm saying equations, 2 different fractions. We want to find the least common denominator with our fractions to make it a little bit easier for ourselves. In regards to that, I find the least common denominator by multiplying 7 and 9. So 9 times 7 is 63. 7 can go into 63 9 times. 9 times 3 is 27. 9 can go into 63 7 times. 7 times 4 is 28. The one that is steeper is the 4/9. Notice how they both have the same denominators. But now 28 is bigger than 27. So that's what made it steeper. So yay for us. Moving on. You have another example, and it's asking you to write a formula or write the equation of a line with the slope given to you as 1/2 and the point is 2/4. Before we move on, this is the ideal time for you to pause this video and jot these 4 formulas down. So the first one is your slope formula. The next one is the standard form for slope-intercept. Next one you have the point slope formula, and then you have standard form. Most of the times we're going to go back and forth between point slope and standard form. So now let's go back to 16. Given to you, you have a slope of 1/2, you have a point of 2/4. So here's the problem in its entirety. So using the point slope formula, I substituted my values in. So my slope was 1/2. I had my point for x as 2, and then my point for y as 4. Notice how I simplified everything, and I stopped right here. Now the reason why I'm stopping, it wants you to write it as standard form. But this right here is point slope form. Well, we don't want any fractions, we want whole numbers. So notice how your denominator is 2. So I multiplied the entire problem by 2. Notice how everything is eliminated now. So there's more than one way to write this. If I subtract 2y from both sides, I will be left to be x minus 2y equals -6. But if I subtract the x from both sides, I'll have -x plus 2y equals 6. This is the preferred answer, but both of them are correct. Now what I did was I skipped some steps, but it's up to you to figure out what I did. So in case you've forgotten, notice right here, I subtracted 2y from both sides and then subtract 6 for this part right here. And then for this one, I just simply subtracted the x. Here's yet another one. Given to you are 2 points. They want to write the equation of a line in standard form. So let me erase this out of the way. Well, one of the first things that I did, I actually tried to find the slope by substituting my points in. The next step, I still substituted the first point in the slope, point slope formula. And once again, this is just like one we did earlier. Please feel free to actually stop it and rewind it so you have a better understanding. I have yet another one dealing with 2 points. Once again, feel free to pause the video. Notice when we get to the very last line, you don't see where it's cut off at. So I'm going to scooch it up just a little bit. And there we go. You see the final answer now. So once again, please feel free to pause it. And notice how it's in standard form. Now I'm not talking that much for this particular problems because we got a few more to go. For the next example, let me scoot this all the way up there. There we go. It just wants you to write the equation of a line in slope-intercept form. So you have your slope given to you as 3/8. You have your y-intercept as 9. So I rewrite it, 3x plus 9. That'd be cool if like all of the problems were like that, wouldn't it? But it's not. Too bad, y'all. Now here we go with a doozy. Given to you in that problem is written out as a word problem. It says write the equation of a line that contains the x as an intercept of 3 and y as an intercept of -12. What I went back and did, I rewrote them using my points. So I got x-intercept is 3, meaning y is 0. Y-intercept is -12, meaning my x is 0. Once I figured that out, I substituted my problems for my points in. So let me label my points so we have a better idea of what I'm doing. So that's x1, y1, x2, y2. Substitute them in. Once I simplified it, I know my slope was 4. Now using point slope formula, I have this. substitute all your values in. But yet again, it wants it in standard form. This right here is slope-intercept form. They want one of these two. So I'm going to put the y over here on this side. So that's now going to be 4x minus y. Transfer your 12 on the other side. That gives you positive 12 because notice how it's a negative. Or you can subtract the x from both sides. That would be negative 4x plus y equals negative 12. Both of them are correct. Now we have our last one. Given to you are the points negative 3 and 7. They want something to be parallel to the line x minus 6y equals 6. Now be mindful, parallel lines have the same slope. So let's try to figure out what the slope is for this one. Well, I did it the long way, but I'm also going to do it the short way. Slope is negative a over b, so that would be negative 1 over 6. That's a negative 6. Two negatives give you a positive. So showed you both ways. This only applies, by the way, for slope for standard form. Now we're going to substitute into your formulas. So we got our point of negative 3 and 7, and we have a slope of 1, 6. Substitute using point slope form. So using distributive property right here, then I stop. I want whole numbers. So my denominator is 6. So multiply everything by 6. So now I have 6y minus 42. The 6 cancel out right here, so bring down the 1, which is just the x. The 6 cancel out right here, so bring down the 3. Depending on what form that it wants, which is going to be standard form, I can either subtract x from both sides or the y from both sides. So I subtracted the 6y from both sides. So now I'm left with x minus 6y. Combine your like terms with the negative 42 and the 3. So the opposite of addition is going to be subtraction. These are like signs. So this one right here is your final answer. So ladies, gents, individuals, my apologies for the rush, but that is an additional lecture for homework for Module 3.